Um. Okay. Uh. Why is it so delayed today? I mean, my microphone monitor. It's so delayed. All right. Let me post. The, yeah, let me post this live on my Twitter X again. I don't know why Elon Musk don't say Twitter X. I know he likes X, but hey, why do you kill the bird? Let me config something. Yep, the limiter is okay. Now, why is it so delayed? Wait. Oops. Okay. Okay, that's it. Regate. We don't use recomp here. Oh, I didn't. Okay. Control device. Okay. Okay. Everything is fine now. Okay, let me. Why is it so delayed? I don't know. Like, it's so delayed, and it. Oh, okay. So it's just a bug. I just turn off the monitor and start again. I mean, turn off the monitor in OBS and start again. All right. Let's see. Hold on. I have to go to my YouTube studio. Hold on. No. Oh, shit. Hey, simple repair. Sideways skin. Okay, you guys don't see my screen, right? That's cool. I have YouTube Premium now, so yeah. What if da 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 yeah, I will have to turn off the virtual gate, audio gate. So when I have to sing, but that means all the noises will get in. But I can use noise suppression. Oh, hello, chocolate. Today I'm early, so congrats. Congrats to me. Oh, but I still cannot like promote it. Okay. Where the hell is everything? Alright, share it to X, and everything will be fine. Let's put in my title. Wait, where's the thumbnail? How is my voice today? Chocolate. I adjusted it to be much louder. So I don't know, what do you think? Yeah, let's put live stream. Yeah, live stream, and I don't think I can put VTuber here. So let's go. I don't care. I don't use my avatar anymore because I want to redesign, but cannot draw as of now. Live. All right. Oops. What is this? Oh, this is game capture. Okay. Oh. Oh, another. Oops. All right. Yeah, that's Sora. The Sora-chan again. Tokino Sora from Hololive. And today we are not writing an API, mind you. We are writing we are writing an API. So let's close this. Oh, okay. I forgot to name this workspace. Let's save the workspace first. Save workspace as I don't know, where is it? Yeah, just save workspace. Save. Yeah, it's my team name, WorkOS. It's not the WorkOS, it's work. It's WorkOS innovation, something in Thailand.ฮะรีเซ็ตเน็ตตั้งนานรีเซ็ตเน็ตตั้งนานนึกว่า นึกว่าค้างไม่ผมก็พูดตลอดไม่ใช่เหรอแล้วยังเปิดBGM เอาไว้ด้วยแต่ว่าหน้านี้ไม่มี BGM เนอะเพราะว่าเอ่อไม่รู้จะเปิดทำไม แต่ว่าเอาเป็นว่าเดี๋ยวใส่ BGM หน่อยละกันไม่เดี๋ยวmedia source BGM โอเคฮะอะไรคุณช ช็อกโกแลตไม่ได้ยินเสียง BGM เหรออ่ะเสียง BGM มายังthis closes workspace and alright I forgot one thing my tablet ไม่คือผมปรับเสียงผมปรับเสียงไมค์ให้มันดังขึ้นแล้วแบบผมปรับBGM เท่าเดิมไงก็เลยไม่ได้ยินปะเพราะว่าปกติจะปรับเสียงผมจะเร่งเสียงใช่ไหมปกติจะเร่งเสียงไลฟ์กันใช่ไหมเพราะว่า ผมเพิ่งรู้ว่าเสียงไมค์พูดผมแบบ-14 เดซิเบล-14 เดซิเบลนี่คือ 1,400 เท่าของการได้ยินปกติของเสียงที่ได้ยินดังที่สุดของมนุษย์เลยนะเพราะว่าดังที่สุดของมนุษย์เดี๋ยวนะดังที่สุดของมนุษย์เขาบอกว่ามันจะทนได้เท่าไหร่20 เดซิเบลเนาะเพราะฉะนั้น0 เดซิเบลคือปกติของมนุษย์แล้วผมเปิดมอนิเตอร์ทำไมวะเดี๋ยวผมปิดเสียงมอนิเตอร์กันนิดนึงโอเคก็คือ ปกติเนี่ยมนุษย์จะได้ยินที่ประมาณไม่ใช่1 เดซิเบลหมายถึง1 วัตต์ต่อตารางเมตรเนาะเพราะฉะนั้นคือหมายความว่ามันอธิบายเทียบอะไรไม่ได้เอาเถอะนะครับก็คือเอาเป็นว่า1 วัตต์ต่อตารางเมตรแล้วทีเนี้ย-14 เดซิเบลหมายถึงว่ามัน1 เดซิเบลเนี่ยนะครับคือ1 เดซิเดี๋ยวนะเสียงเพิ่มขึ้น1 เดซิเบลหมายถึงเสียงเพิ่มขึ้น20 เท่านะครับ20 เท่าของ1 ตารางเมตรอะ1 วัตต์ต่อตารางเมตรเพราะฉะนั้นว่าเดี๋ยวนะโน้ตบุ๊กผมจะร่วงWait, where's the clip? Oh, there's the clip. First. Oh, wrong.ฮัลโหลเพราะฉะนั้น-14 เดซิเบลหมายถึงเบากว่าเสียง1 วัตต์ต่อตารางเมตรเนี่ยประมาณไม่ใช่ประมาณก็คือเท่าไหร่วะ20 เท่า240 เท่าโอเค280 เท่าครับ2,800 เท่าเลยใช่ไหมเถอะนะครับคือมันเบามากว่างั้นเถอะอ้าว คนเลี้ยงแมวนี่ลำบากนะครับคุณช็อกโกแลต คือต้องมองมันทุกวันเลยต้องมองมันทั้งวันเลยผมอยู่คอนโดมันเลี้ยงสัตว์ไม่ได้ก็เลยนี่ไม่ได้เอาละ Let's start with a new file and yeah let's say it's md MD. Wait, เซฟไว้ที่ไหนเดียวเซฟไว้ที่โปรเจกต์แล้วกัน So you guys see I have another clip, another project there. Yes, it's I will be making some clip about writing an API. I've been recording and the file is 2 hours. The entire API is 2 hours. It's actually not from the scratch, but just one API. I will try to make it much more digestible. Now, let's go back to reinventing AI. ML actually. Machine learning. And artificial intelligence of machine learning. By the way, machine learning also encapsulates chaotic system control, which is more commonly used PID control. But that is just control, it's not learning. The system just go to the optimized state over time and then stay there. PID is always used for robot motion. By the way, I don't have my avatar here. Maybe I should put it somewhere. It's browser source, isn't it? Oh, okay. Wait, why isn't it jump? Why isn't it? Why it doesn't jump? Wait, what? What? Sorry. My Discord is bugged. My Discord bugged, so I will try later. Yeah, I'm capable of writing the jumpy head myself, but I don't. Discord. I use Fuji because it's simple. And I always log into Discord, so nothing is my cost here. The only cost in using Fuji is I have to deal with Discord bugs, which is bugging right now. I really don't understand. What? Oh boy. Why is it buggy? Why? Oh. Oh, it detects the sensitivity. Oh. Okay. So Yeah, it works now. Okay, so back to PID control. PID control is chaotic system control, which try to optimize the power output of a system. And I come from electric. No, actually, I come from software engineer, so I only knows that it works with electric motor. Well, it works with every mechanical systems, but uh, I only know how to use it in electric motors. You need sensors. You need uh, power control, and then you need the control system. The power control means the power supply that can control power. That's it. And then you feedback from the sensor. You calculate from the PID engine, and then you use the PID engine to control the power output of the system. Why it needs to be that? Well, if you don't control the power output, you will get overshoots or undershoots. Overshoot means the power supply doesn't know how the things that connected to it works, so it output maximum power to the device, which is electric motor in this case. The power supply output 11 volts, output 11 amperes into a DC motor, and the DC motor spins and then generate back EMF, because motor is also a generator. So it can generate power back to the power source. So, and then 11 amps sees the power from motor, and it becomes 8 amps, and then the power supply try to compensate for that, so it makes it 11 amps again, so the motor spin faster, and it becomes 8 amps again, and it oscillates. So the power becomes 11/8, 11/8, and sometime in the future it becomes 6 amp to 4 amp, 6 amp, 4 amp, and 2 amps, 1 amps, 2 amp, 1 amps, and then stable at maybe 1 amps. But overshooting means the power, if the motor cannot withstand the heat that comes from the power source, it will just break. It will just burn. And even though if it could withstand the heat, if the shaft is too weak, or anything that connect to the shaft is so weak that it cannot like hold 100 watts of power, it will break. The structure will break. So that's why we need PID control. And in some case, for undershooting system, the motor will not spin, or spin too slow to even be able to use. Okay, that's enough for ML. For just control ML. But now we are talking to the ML that is intelligent. What is ML that is intelligent? It's an ML that can generate different outputs from different inputs. uh, and it doesn't remember one setup, like unlike the control, because the control, when it gets to the optimum setup, it just remember that and never learn again. It might learn again in set intervals of uh, engineer of what engineer wants to maintenance. So yeah, um, they want to maintenance the control system because it can be rust, it can be what do you call it can be lubrication degrade, so it's sticky. It gets sticky, and when it gets sticky, it overshoots. The power source overshoots, and and it draws more power without outputting more power. So they will know when to change the oil, or when to change the grease, when to change, or maybe when to calibrate the tool. Like if the motor move the motor is moving the needle, then that needle engraves something on the surface, and the surface mismatch from the reference. So they know that the system is out of optimized state. So they can just calibrate, or they can just change the part entirely. But that's engineering. That's mechanical engineering. Which is not my expertise, but I know because I'm also an engineer. Also, now in computer, we are talking about ML for mostly intelligent system. And what is the intelligent system? Well, do you see this top menu? Search bar. This is intelligent system. It try to find matching pattern like markdown, which doesn't exist because it has this preprocessor and markdown. See, it's try to recognize spatial character. It tries to recognize the pattern. It also, yeah, this spatial character brings me to the line. See, this is intelligence, but that's intelligent system without machine learning, because this is indexing. They just try to index everything. Indexing means just put them in order, just put number to the data, and then they just index. And it not putting number to the data, it just point to the data. So it tries to find the correct index of the correct pattern. And usually there's a lot of search algorithm, which I won't go there because that's the whole class of data structure and algorithm, which can make a lot of programmers tears out of their eyes. But I find fun. I just don't remember them. I just remember the fundamentals. I don't remember the algorithm. Why on earth do I do that? Because we have medias, we have we have writing system to accumulate for our brain. Accumulate. Sorry. To account for what our brain cannot conceive. I mean, cannot persist. is extra memory. So back to machine learning system. The machine learning intelligence system, artificial intelligence. Well, if we are talking about AI before past 10 years, we are talking about games. We are talking about enemies in games, the AI enemy. That is just intelligence without machine learning for most of the games. Those are like just have the pattern that they can talk, that they can think about. So I want to move my I want you to see the time. So where's my time? Okay. Yep. I want you to see the time. I didn't put the timer on because I didn't write it. I didn't rewrite it. Remember, my old PC went to heaven. Maybe hell. I don't know. Okay. Now we are talking about more comprehensive AI. Pattern recognition. Pattern recognition is, well, it's not indexing now. It's try to recognize something and try to predict from what it recognizes. Like OCR, what is OCR? Optical something. Let's see. Optical character recognition. Yeah, so what is OCR? OCR is how your phone can read your paper, your documents, and then it helps you to like scan a page and make a PDF, which the computer can understand, and it's not a picture, which, well, Thai government doesn't use this. This is so stupid. Wait, what the fuck is OMR? I'm sorry, but I have to know. What is OMR? Optical mark recognition. Wait, what? Detect marks on the paper. And what is the mark on the paper? Began with punch hole system. Oh, based on how the marks are made. Okay, so OMR is like it's just prehistoric OCR because it just detect marks, detect a predefined a non-human readable pattern, like the barcode or QR code, quick scan code, by the way. So they have, so the marks on the paper or on any media, any surface, usually well structured. Well structured means it follows every instructions on being a pattern, and it follows strictly. Oh, I forgot about the BGM. Sorry. Okay, so they follow strictly. Then the OCR, it can read handwriting, and every handwriting's very vastly different. So so it tries to guess, and guessing process means prediction. So the reason why I didn't start doing anything, because I just want to introduce. Okay, so OCR is more sophisticated intelligent system than a search bar, because when you read the pattern, you recognize the pattern, you found the boundings box of a character, and you try to evaluate how close it is. So you use the statistical data of the marks that form the pattern, and then you average it out and you compare the deviations to the least deviation, I mean the least different pattern in the repository will be chosen as the data. Like if we had let's say paint, like if we had a pattern of number 1, which I think I will do this instead. This is the pattern of number 1. Oops. Yeah. This is a pattern of number 1. This is a pattern of number 1. So if I write this one, or I write this one, well, this one, it might be like around 80% similarity. But if I wrote this one or this one, it might be around 60% confidence. Because like if we already have this pattern, the number 7. Oops. Yeah, if we had this number 7, and if I write this, oh sorry, oops, if I wrote this, oops sorry, this or this, it might say 70%. No, actually this is around 90%, 99% I guess, and this is about 70%. Yes, and it's actually my natural way to write 7. Some people even use this, and they might be like 40%, because it's more likely to be number 2. Actually, it's more likely to be number 2. And someone even write this, which is obviously number 2, right? But what they mean is number 7, or maybe they wrote this and it looks like 9 more than 7. This is the hardest number, I think. By the way, if you wrote 6, 9 and 8, these numbers are also similar. By the way, 2 and 9 could be the same, like this or this. I don't know, like this is computer. They cannot think. So because computer cannot think, you have to admit that. It just calculates, it doesn't think. Think in philosophical aspect, so it's not just think. Earth 1711 สวัสดีครับมาใหม่ละสวัสดีครับคุณเอิร์ธผมก็ไม่เคยเห็นคุณเหมือนกัน นะครับยังไงยินดีต้อนรับสู่ช่องผมนะครับพอดีผมคุยเรื่องเทคนิคอลมากๆเลยนะครับก็เลยแบบว่าไม่ค่อยได้ไลฟ์เพราะว่าปวดหัวตอนนี้มานั่งบ่นนะครับ Reinvent ML ก็คือเหมือน Reinvent the Wheel ครับประดิษฐ์ล้อขึ้นมาใหม่อันนี้ก็ประดิษฐ์ Machine Learning ขึ้นมาใหม่แต่ว่าตอนเนี้ยกำลังเกริ่นอยู่ว่า Machine Learning คืออะไร AI คืออะไรนะครับผมเพิ่งเล่าเรื่อง AI ที่ไม่ใช่ Machine Learning นะครับแล้วก็กำลังจะขึ้น Machine Learning แล้วนะครับแต่ว่าเวลาก็ใกล้จะหมดแล้วเหมือนกันนะครับ แล้วก็จริงอยู่ที่ผมพูดภาษาไทยเร็วกว่าแต่ว่าผมคิดเป็นภาษาอังกฤษเร็วกว่านะครับขอโทษด้วย Alright so this is OCR oops this is OCR optical character recognition it's a pattern recognition just like the search bar and I think this is the closest AI anyone would ever think before 10 years ago. And then, no, actually, the machine learning was like right in the day of Turing, which is father of computing. So, yeah, machine learning is the oldest topic that isn't solved, but it's actually solved in 10 years ago. So we are just following the footstep, right? I'll delete this. Why? Pen bucket. Okay. Now, what is ML, by the way? What is ML? Oh, okay. What is ML, by the way? Machine learning. Machine means computer and anything that attached to the computer, like the electric motor when I talking about PID. And another thing is the OCR system, your phone, even your refrigerator, even your air conditioner or your fan, your smart fan, I guess. Okay, so machine learning. What is machine learning? Machine learning means that a computer, a machine, machine that can adapt to environment. So yeah, the environment can be anything, but the machine also knows that and it tries to adapt. This is machine learning. But how do they do that? Well, agent means agent means intelligent agents. Intelligent agent is the computer. Computer. It has to sense something. This is sensor. So ENV is like a sun. Yeah. Agent and sensor. In most well, sorry. So this is the simplest explanation, but in most I think in most books will tell you that between agents and sensor you have a computation unit. because the agent is actually model actor actually. It is the output to the environment. So the computer is actually here, but I think why do you have to change both of them? I mean, why do you have to split both of them? Like, the agent can think and act, that's all, right? But yeah, this is canonical. This is how they will teach you. Like, an agent will have computer and sensor. The sensor is here, by the way. Sorry. Oops. I forgot that I have to right click. Yeah, so yeah, this is intelligence agent, and the entire composition here is machine learning system. I will call ML, not MLS, because it doesn't make sense. The S here doesn't make sense. So ML. This is the entire composition of ML, the entire architecture. Oh. Oops. Yep. And the brush. Anyway. So why do I want to reinvent the ML? I don't actually reinvent the architecture. The architecture is still like computer, agent, connect to an actor, and also connect to the sensor. This is the correct diagram for ML architecture. This computer can also be transformer or anything that people can say. Like, these can be called transformer. And half of an agent is this is encoder and this is decoder. This is the modern ML architecture. Basically everything, like from smart search to what is it? Word suggestion, to Mid-Journey or any neural networks. Now, my reinvention here, I'm targeting, I'm targeting specifically the neural network. Oops, network is here. The NN. how the neural network works. It works like this. It has a node and a node, in and out. This is sensor, this is actor. This is the simplest one, but here can be hidden layer of, you guess it, nodes. And this layer can be like multiple layers. So, yep. This is cool and all, and I will do this too. Maybe because this is what I'm targeting. Why do I target hidden layers? Well, I didn't actually target hidden layers, but my target actually like either requires or change the meaning of it. Like this is neural network, right? But in fact, the full name is DNN, or digital neural network. Digital neural network. Oops. Yeah, digital neural network. But how does the digital neural network works? For each layers, like node, right? For each of these arrows, for each of these, they have a function here. And this function, actually, they most commonly use the C. So, yeah, they most commonly use this signal. For this function here, most of them are like, it can be a threshold detector, like, oh, sorry. Or like sigmoid function. No, actually, yeah. Sigmoid functions. And it can be any function at all, like that exists. This is logarithm. Yeah, it's a threshold function. But this threshold function calculates a lot of them. So for each node, this would be written as sigma s, sigma phi. It's sigma phi, yes, but this sigma is maximum at 1. So this function is, well, it's like having a range of 0 to 1. By 1 means there's only one connection that comes here, and it will become a switch. So how do they get from 0 to 1? It means this sigma function isn't actually sigma, it's actually an average sign. So it's actually so yeah, it's the average. So why do I target this? The reason is this is not how your neural network works, like how your brain works. This is how statistic works. It's how parametric statistic works. And you don't think in statistics. Statistic in your mind is intelligence. I mean, it's more than intelligence. It's information. Well, yeah, information is intelligence. But anyway, you have the data, then you evaluate it. You don't evaluate before you can read the data, but the neural networks nowadays works like this. It averages the signal. It averages the signal, and that is what I don't like. And also, one thing to consider: it assumes that the neural network assumes that you have to go past all the layers to get the result. คุณจันดำสวัสดีครับไม่ได้เจอกันนานเลยสวัสดีคุณช็อกโก้ด้วยนะครับ ไม่ได้เจอกันนานเลยแต่ผมจะลงไลฟ์แล้วครับเพราะว่าผมมีเล่นโปรเจกต์ซอมบอยกับเพื่อน นะครับแต่ว่าเดี๋ยวผมเกริ่นตรงนี้ให้จบก่อนนะครับตอนนี้ก็คือทำไมถึงต้องมานั่งประดิษฐ์ไอ้ machine learning ใหม่นะครับแต่ผมพูดเป็นภาษาอังกฤษ Welcome though Welcome everyone though Okay So modern DNN assumes that you have to go through all of the layers in the network just to get one result, and then the human user trust the result. I mean, not trust it, they verify, but yeah, they take it to take it as granted. By the way, the user can be not human. Like you can put neural networks together, and then the result can also stream to any other agent, AI agents like search bar. For the record, anyway, they do that. And this function, by the way, is beyond my mathematical knowledge to explain. I don't know if you can find anyone to explain this, but the only VTuber person I know is Navi, but I didn't talk to her like ages, so I don't know if she still exists. Anyway, so this function is the entire algorithm. This is algorithm. So this is where research and development happens. The entire architecture here is just there. Well, yeah, it is the same. So yeah, So the entire architecture is just there. This is the architecture of this module, of this DNN module, and the whole ML architecture is the above portion of this image. I will delete this. So why? So why do I want to reinvent? Well, DNN is good and all, but your brain doesn't work like this. DNN, I will say it's stats. That's all. That's all the DNN is. It even used what do you call conditional statistics. It didn't use that equation. Yeah, probability. It used these equations literally just to evaluate data between layers. I don't know why. Like, why do you want to do that when the organic the organic neural network, I will say on, say how organic neural network works. Well, there's a nucleus here. This is DNA. This is dendrite, right? This is cells. This is neural cells, by the way. It is the node. Is it what nodes wants to be? And now we have what is it? What is this? I forgot, sorry. Dendrite and wait, what? Neural cells. Neural cells. See, yeah, axon, dendrite, like this. And yeah, Schwann cells. But the Schwann cells doesn't exist in computer, so yeah. See, this is what I supposed to draw, but yeah, I only have so much time. So this is axon. This is, what do you call? This is axon terminal. And myelin sheaths and Schwann cell something. Well, I will bring up this image later. Yeah, Schwann cell, myelin sheaths. Well, node of Ranvier is, well, I think it's axon. So why do I have this image to you? Yeah, see, this doesn't have myelin sheaths. Why do I show this to you? Because I was thinking why people don't write code like this. Microfibrial. Anyway, we can think of those myelin sheaths as accelerator, like GPUs or anything that can speed up the transfer or the calculation. You can think of that. But how does this works, by the way? Like this monster, how does it work? Well, it's a cell, right? You see these 2 dots? These are mitochondria, the powerhouse of the cell, right? So how do they think? They don't think. They just have threshold. So it's this function. That's it. That's all. Like not even sigmoid function, but well, this looks like C, the function we saw before, right? The transformer function, actually. Well, this is how cell works. It detects threshold and it fires everything above the threshold. But if the threshold isn't enough, it will just hold the state. So instead of the reading as like if threshold is like 0.5 and the signal is 1, then the output is 1. Sig at 0.8, sorry. The output is 0.8. Now, if what happens if sig is 2? Then the dendrite only have so much capacity, so output is capped to 1. That's it. But what happens if signal is 0.4? Then the output, well, in the DNN system, it's stats, right? It will become 0.4. DNN 0.4. But for organic system, it's just straight up 0. Well, not really, but it can be like or 0.02 something, leakage voltage, I don't know. Cells is not diodes. Yeah, so why don't you just do this? Why do you like average things? Oh, by the way, the average. So this is how cells thinks. Yeah, this is how cells thinks. So what happened about average? Sigma C is sigma C. That's all. Sigma C is sigma C. That's all. Like, why do I have to divide it by n here? I don't understand. And you know, in computation, this took like 20 cycles. Yeah, this took like 20 CPU cycles per calculation. And what does it mean? 20 CPU cycle per calculation means 1 million calculation for like 50,000 cycle. 50,000 nodes. And what 50,000 node is? Well, take image processing. What happened if we fed 500 times 500 pixels? A small pixel indeed. See, that's 250,000, right? But because of 20 CPU cycle, it becomes it becomes 5 million cycles. And and yeah, 500 times 500, and the computer cannot input 25 205 25 oh sorry 250,000 inputs at the same time จันดำหนูฟังนะแต่ฟังไม่ออกกันนะผมคิดว่าผมคงพูดลิ้นพันกันบ่อยอยู่นะขอโทษด้วยแต่ผมพยายามจะฝึกพูดให้มันชัดอยู่เพราะว่าคนที่พูดภาษาอังกฤษในไลฟ์จริงๆเขาพูดชัดกว่าผมเยอะเลยใช่ไหมล่ะแต่หลายๆคนอะแบบเอาจริงผมก็ไม่ค่อยได้พูดกับคนนะครับก็เลยแบบว่าพูดกับตัวเองมันก็เข้าใจกับตัวเองไงนะครับก็เลยไม่จำเป็นต้องพูดให้มันชัดบางคำก็เสียงหายเพราะว่าไม่ใช่แค่เพราะไมค์แต่คือมันหายจากปากผมจริงๆก็มีนะครับ อันนั้นเรื่องปกติของคนที่ไม่ค่อยเข้าสังคมเลยนะครับเพราะฉะนั้นเวลาจะคุยกับคนอื่นก็เลยต้องพูดให้ช้าแต่ผมพยายามจะให้เวลามันกระชับผมก็เลยพูดให้เร็วนะครับโอเค Computer cannot read this. Why? Because of register, because of the CPU register and all sorts of computer architecture that I cannot explain today. Well, actually they can. They can. Hold on. No, they cannot because the maximum L1 cache is nowadays though 156k. 156k. Well, so it can do that. It can put the entire 500 by 500 square into the picture. Of the picture into the register and calculate them all in one go. This is L1 cache. This is the limitation, the hardware limitation. So yeah, this is the maximum input for one cycle. By the way, no. This is the maximum bytes input, but we know pictures has 3 bytes per pixel, right? So we have to divide it by 3. So for any picture, we can only let's get this back. For any picture, we can only input the maximum of 85,000 pixels. No, 85. Well, yeah, square root. Oops, what the fuck? Sorry. Hey, we can input 85,000 pixels to one cycle of CPU. Now, what happens if we squared? Which means if we input a square picture, right? What? Wait, why is it becomes square root of 3? Why is it become square root of 3? Okay, square root. Okay, so the maximum picture size, the maximum square that can put into the CPU and it can works in one cycle, it is not even 300 by 300. It's just shy of that. It's just 292 by 292. That is the maximum. And don't forget file descriptor. Don't forget the functions description. Don't forget the random bytes. Don't forget a lot of things. Like, so 200 by 250 by 250 is the maximum pixels that can get into L1 cache for AI evaluation for any like image processing. By the way, this is depending on what version of the CPU that we are talking about, but most of them have L1 cache at 256K. So that's it. This is the limitation of majority of CPUs. เราคงไม่ได้เจอคนนานละมั้งอะไรเนี่ยเพราะไม่มีใครจับอ่านว่าอะไรสนองมินิคืออะไรวะ โทษทีนะครับคุณจันดำคุณจันดำก็คือคุณ Black Moon ใช่ไหมครับ Black Moon ชื่อโคตรเท่เลยชื่อภาษาอังกฤษคุโรสกิชื่อภาษาญี่ปุ่นใช่ไหมนะครับOkay, so that's the maximum of majority of CPUs. How about GPU? GPU has well, they use VRAM instead, but to calculate VRAM, they also use L1 cache. Oh, they also use CPU L1 cache to stream data into VRAM, but streaming data doesn't take a lot of effort. What takes a lot of effort is the core, the GPU core. So what is the GPU core? Well, I mean, how large is GPU core? It's as large as the bit depth it says. Like one core is nowadays for NVIDIA's and AMD, both of them, one core is 255 bytes. No, not bytes, bits. 255 bits. So one core can only works on 255 bits. So it's like 1,000 less than what we just calculated. So the maximum is 250, right? By 250. Now we divide it by 1,000. Sorry, 1,000. So 62 by 62 square of picture can be processed in one GPU cycle. Or actually, most of them will be 64 by 64, which means they put the other parameters aside. Now, that's one cycle. Like you have 600. No, you have like 1K picture. You have like what is it? Let's see, Rita. You have an A4 600 DPI. No, PPI actually, pixel per inch. Like new file. This is open source, by the way. See, even A6. What is A6? You fold A4 2 times. That's A6. As small as your phone. This is how much pixels in one dimension, and GPU can, like, one core can do like 64 by 64. Now most GPU have like 4,000 cores. So yeah, we are back to L1 cache again. But that's it. It just 4,000 cores, and like NVIDIA 4080 Ti, I think they have like 30,000 cores of 128 bits. Well, yeah, so they can process this in 30,000 rounds of their clock speed. Of their clock. And most of them have like million clock speed per second. Like, yeah, clock speed. Clocks per second is clock speed, sorry. Imagine dividing a number of neurons for like that much amount of time. Now, if you have more than that connections, you can lose more speed. By the way, this is why I think we should just get rid of this, and then max of this function. Yeah, just get rid of this. So max of C I think it should be 1 byte. And then we allow the overflow, because our brain works like that. Our brain just cannot handle larger signal, and it just dies when the signal is too large. That's it. Now this is max C, 1 byte. How much is it? It's 0 to no, actually 1. How much is 1 byte? Is to the power of 8, which is 256. So yeah, 256 values. And then we can just check. We can just check the threshold by any value between these. Now, what does this mean? The problem is when you have threshold signal. When you have threshold signal, it means you are sending like if the threshold is 128.7, which is half of the 2 by, this is 2 by 2 power 7 minus 1 equal to this, which is actually 2 divided by 8, 2. Yeah. So this is half of that value. Then Cn is 127, right? This is problem. But if we can say just look at the activation, just not do this, but do this, equals to 1. What happened? Well, it won't activate the next cells, right? It won't activate the next cell. Which is this language? sorry, I'm talking in English, but my chats is all Thai except for you, Rohan. Welcome to the channel. And what is this language? Yeah, I write in English. I talk in English. And this, well, wait, I didn't turn on the seeker. Anyway, the fee is actually functions. It's actually the transformer function. That's it. And the CPU count, I just want to say that the DNN has limitations on the speed of hardware. Well, any calculation has that speed. And division takes like 20 CPU clocks most of the time. So why don't we just don't divide? We just use the whole byte. No, actually, this is not correct because integer is 16 byte. It's 16 bits, which is equal to 4 bytes. I'm sorry. I just thought of that. And it's like 2 to the power of 4 times 8. 4 times 8 is 32, right? No, sorry. It's 16, sorry. No, it's 4 bytes. 2 bytes. So this is 2 bytes. So this is 2 bytes. So it's 2 times 16, and this is, yeah. So if the threshold is half of that, and we just allow the entire data to flow, the number will overflow. And 1 neurons. Yeah, this is neuron, by the way. So neuron. Oh, which it, and if you are asking about language, I mean language I will be using to develop this one, I think it will be C++ or C or natives or natural C. I don't know, because although I can write JavaScript, I cannot find a good way to manipulate bits correctly in JavaScript. Maybe Python, I don't know. We are just in the designing phase, and actually this is just introduction, and I'm over time, like 40 minutes over time. So the philosophy is we don't divide. Oops, sorry. Divide. How do you write divide? And C should be easy to calculate. It could be linear threshold, or it could be sigmoid threshold. Sorry, sigmoid threshold. Because sigmoid is easy to calculate, actually. And the third one being that we only care the state of the dendrite that connects to the axon. So axon state reading. What does it mean? It means, okay, as boolean though, as boolean. So if we can do this is working like actually more than it working like our brain, because our brain don't divide, just sum and then read the state. Now what's more than this that I don't talk to today, I will talk in the next part, is this reading neuron pattern. And also I will be using SQL for for the model because I am too lazy. And 5 neuron pattern, and 5 evaluate output stream. So what DNN don't do is these two. I want to add these two to the equation, to the system. So I simplified the existing system to actually reflect more like the brain, but then I add more complexity by trying to read new structure of data, because well, DNN is stats, it outputs raw data, but organic neural network, oh by the way, another philosophy, another target that I'm talking about next time, not this time. So see you. I'm about to, I have to go to play Project Zomboy with my friends. So see you. I'm sorry saying this, but hey, why is it new folder? Anyway, I'll save it here. Bye. See you later.